Hey y'all. Homework you can check online for yesterday's stuff. Obviously, remember you can always go to bit.ly/WeGo Advanced Algebra, all lowercase, and come up with things. So all your answers are going to be over there, and we'll go through and talk about things there. Everything we're doing today is going to be building upon that. So with that being said, we're going to go ahead and just jump right in. Again, remember, please pause and rewind as you guys need to. We're going to review a whole bunch of stuff from first semester today, and then tomorrow we're going to build upon it with bigger roots. So, um, what we're going to be working on today, properties of rational exponents to simplify expressions, simplifying the following radicals. So again, this is stuff that you know how to do. We're going to review a couple of things to make sure that your skills are right where they're supposed to be, because if you can't do it with square roots, you're certainly not going to be able to do it with cube roots, fourth roots, fifth roots, stuff like that. So there's a couple of different ways you can go about it. The easiest way to do it is off on the side of your paper, and don't just have one piece of paper that you always refer to do this. Do this on every single time you come up with a piece of paper. Is I would just start doing things, and I would just say, here's the squares. 1 goes to 1, 2 goes to 4, 3 goes to 9, 4 goes to 16, 5 goes to 25, 6 goes to 36, etc. And you're going to keep doing this. And the reason why it's good to do this each time separately is A, obviously it builds some skills. But the other thing that it does is that when you're doing it, it's going to familiarize yourself right before you go into a set of problems of things that you need to do. Just like, no, it's 16 squared, 196. Sorry. Um, just before you do anything, before you go sing for a concert, you warm up a little bit. Before you go play a game, you warm up a little bit. And this is going to get your kind of head in the game. And I'm not saying stop this right now, etc. Copy all these down, but this is just so that you kind of have, so when you're looking through numbers, you can say, oh, that's a perfect square. Oh, that's not a perfect square. Oh, I can break this down. So when I get to a problem like this, easiest way, if you know what the squares are, is you can say, hey, look, I can write that as the square root of 9 times the square root of 2. If you really want to have like an in-between step, you could have the square root of 9 times 2. But and then at that point, it's going to say, oh, that's 3 root 2. Yay! Now, some of you may, and and that's why it'll go faster that way. One of the things is that some of you may want to say, oh, well, let's write it down like this, and there's going to be some utility to doing it this way. Let me scroll down just a notch. Of saying, okay, well, 18 is 3 times 6, and then this breaks down into 3 times 2, so this is really 3 squared times 2, and you're breaking it down that way, and so then you're going to have the square root of 3 squared times 2, so the squares take each other out and you can get 3 or 2. That's fine, but that's going to end up taking longer, and it's good to do in a pinch if you can't see stuff. That's fine. But again, you should hopefully be well versed enough on some of this. So like up over here with 28, what perfect squares can I break out of 28? Well, hopefully you're seeing this as 4 times 7, in which case then the square root of 4 is very nice. And you get this. Okay. So again, remember what you're trying to do is, since the index number is 2, that's going to be the groups of 2. You're going to look for numbers that happen twice. So like in this case, actually, you would break this down. You could also break this down into 2 squared times 7. And so anything that's squared, you can say, okay, that comes out. I had a friend of mine who I was in graduate school with, and she talked about how it's like jail. In order to break out of prison, you got to have a partner, and then the only problem is that one of them gets shot on the way out. I'm not saying it's great teaching, but it's certainly memorable. So, and then tomorrow, obviously, if we're doing cube roots, we're going to look for 3, 4, whatever it turns out to be. So like here. So again, remember my index is 2. So looking for pairs. So 25, the square root of 25 is 5. But you can write this down as 5 squared. I have x squared. Y to the 4th. There's 2 of those. Actually, you could even break it down like this if you wanted to. Let's break it down like times x times y squared times y squared. So I'm just breaking it down into things that I know we're going to be able to pull out. The 5 squared is going to go out front. The x squared is going to go out front. The y squared is going to go front. This y squared is going to go front. And this lonely old x is just going to be like Mr. Hayes at a middle school dance, all by itself over in the corner. So I get x times y root x. And then we'll simplify all that. I'm going to get 5xy squared square root of x. And again, the reason why we're doing this is so that we can have a standard way to be able to talk with other people intelligently about math. Okay? And yes, I realize that some of you might be able to go straight from here down to here. Okay? I would just caution you that you really understand what's going on. Because if you're just going to try jumping down to there, then usually what ends up happening is that people will end up having issues when we start talking about higher indices of, 3, 4, 5. So just be careful. So you have been warned. Another one. Hey! So this you can break down. And again, how many? I have a total of 7 x's here. So I've got x squared times x squared times x squared times x. 1, 2, 3, 4, 5, 6, 7. And then I've got times y squared times y. Everybody with the x squareds gets to move out front. They go out front. These guys are by the lonesomes. So I get x times x times x times y, square root of x times y. Some of you may remember that, you can go through and, x to the 6th, the square root of x to the 6th is equal to x to the 3rd. And if you're okay with that, that's fine. But again, you really need to understand what's going on. So when we up the game tomorrow, you will see what's going on. Again, pause is necessary. Ooh, 48. So how do we break that down? So 48. Now some of you may see this as 16 times 3. 16 is on our list, remember? Hey, look. 16's right there. Okay? So we know that that's going to work. So then from there, so I can rewrite this as 16 times 3 times x squared times y. And again, I have 5 y's here, so I've got 2, 4, 5. Who's going to make it out alive? The 16, the x squared, and those. So square root of 16 is, again, remember, this is really 4 squared. So that's 4 times x times the y times the y. Because remember, if it's a square on the inside, is equal to anything that's a perfect square on the inside happens just one time on the outside. And then these guys that are solo artists get to stay on the inside. So my final answer here, 4x y squared square root of 3y. Put it in a box, and you're ready to rock. Yay! And again, we're building skills here. You can't do the big fancy stuff until you can understand the small stuff. Now, in problems like this, the easiest thing to do is to simplify this together first. And there's a couple of different trains of thought here. Now, you can rewrite this as 3 times 2 is going to be 36. I'm going to have x to the third, y to the 7th. And then from there you can break things down. 36 is a perfect square. Okay, I'm going to try it this way. I'm going to write it as, okay, 36 is 6 squared. So that's going to come out. The x's I can break up. I need a total of 3. There's 2. Plus 1 is 3. The y's I'm going to break up. I've got 2 there. Another 2 there for a total of 4, 6, 7. And anything with a square is going to be written as a single on the outside, because it has the little exponent thing you can kind of think as a ticket to get out. So I got 6 here, x, and this is going to turn out to become y to the third, square root of x, y. Because again, I've got, you know, I've got 1 here, and then I've got 1 here, and 1 here, and here, and here. So I've got 3 y's, that's why it's y to the third. If you would rather write it out as 6 times x times y times y times y, square root of x, y, and then move down to here, by all means, that would be fine. I think this is the last one. Same thing. Now this one's not going to be quite as cute as the last one. So here I get 10. 10 doesn't break down into anything fun. X to the 7th, y to the 5th. And again, you could potentially break down the separate roots separately, and you could write that as, like, you know, you could break out, I could take out a couple of the x's from the first one, take out, you know. And the reason why I don't suggest doing that is then you then have to recombine all the radicals, and then you have to pull things out again. And I think for most people, it's just easier to combine everything into a big group and then break things down. So here, I can rewrite this as, now 10 is nothing special, because 10 is 2 times 5. There's no squares there. Nobody has a partner. They're going to be by their lonesome. They're going to sit around and complain about not having dates to prom on the inside. But that's okay, because as I say a lot of times, what are the real odds of you seeing anybody you date in high school after high school? You know, you're going to go off, go to a good college, hopefully get a job, move to Montana, you know, all that good stuff. Plus, you can always block them on, you know, Instabook and Facegram and all that other good stuff. So anyway, so anybody with this, again, anybody with, let's see, let's go through and highlight this time. So they're going to get out, 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 they're going to get out. And everybody else, so they're all going to be written as singles on the outside. So that's going to become x times x times x times y times y. So everybody here gets a ticket out. And everybody else stays in the radical. So I get x to the third, y squared, square root of 10x times y. Got to learn how to make a bow. If I'm going to put things in a box, we might as well put a bow on it too. But anyway, so there's that. That is just so spiffy and spentabulous. All right, I believe it is time to work on homework now. Obviously, you can go back and watch this. I'll put this up on the YouTube channel. I'll put a link out on the calendar as well. What calendar, Mr. Hayes? We have a calendar? Yeah, I know, it's a shock. Remember, if you go to bit.ly/, oops, wrong class. I was going to go ahead it. We go. Do it up over here on the side. So bit.ly/ we go advanced algebra. So WEGOADVALG, all lowercase. You'll be ready to rock. So you're going to work on your worksheet. Go through that. Obviously, if you have stuff from the last 2 days to work on, please do that. And I will see you guys next time. Thanks for playing.